Okay, so this is an easy chapter, and the important aspect of this chapter is experimental. This is why to facilitate on you the issue, I try to find several YouTube links, okay, and they are posted on Blackboard in the YouTube links section, where you have different links to see directly how you can do experiments with the measuring tools. Okay, so in this chapter, we will introduce dimensions, tolerances, and related attributes, and we will see what are the conventional measuring instruments and gauges. We will learn properties of surfaces and what are the measurements we can do on surfaces and the effect of manufacturing processes on the surfaces on which we are doing. We can do several, it depends on the manufacturing process that will affect, for example, the surface finish, if it is rough, if it is smooth, etc. So we will cover these ideas in this chapter. To start with, you know that dimensions and tolerances are very important in manufacturing. These factors determine the performance of the manufactured product other than the mechanical and physical properties. So whenever you want to come up with a final object, you should say, this is my draft. You will do a draft and put the dimensions you want. But you know that in any manufacturing process, you will not be able at the end to get 100% the dimension you want. This is why we say we have a certain tolerance range. Okay. Now, concerning dimensions, they can be linear or angular. So you can specify the length of size, you can specify the angles if you have curves, etc. Okay. And concerning tolerances, they are the allowable variations from the specified dimensions that are permitted in manufacturing. And the manufacturing processes will vary in tolerances. So you have some processes that will give you that are not very accurate, so you need to have high tolerance. While if you have a limited tolerance, you need to go with more advanced manufacturing processes. Now, what is the definition of a dimension? A dimension is a numerical value expressed in appropriate units of measure and indicated on a drawing and in other documents along with lines, symbols, and notes to define the size or geometric characteristic or both of a part feature. What do we mean by this? So, for example, you know that for dimensions, let's say for length, you have several scales. You have, let's say, the SI scale, which is in meter. You have the English scale, which is in feet. Okay, so what you do is how they define a certain length. Let's say to define 1 meter, you can bring, let's say, a certain rule. Okay, and you put it, you put that this rule has a dimension of 1 meter. It will be used as if you want a defining for characteristic of meter. So here for the scale, you can come up with any dimension you want. Just you should define it once, and it will be a reference for any other length. Okay. Now, the dimension will indicate the part size desired by the designer, so it will not include errors, but as we said, tolerances will indicate what is the margin of error in the manufacturing process. So by definition, the tolerance is the total amount by which a specific dimension is permitted to vary. The tolerance is the difference between the maximum and minimum limits. And variation occur in any manufacturing process, okay, because we will not have 100% the size needed. And tolerances are used to define the limits of the allowed variation. So before choosing which process you want to use, you should know what is the tolerance you have. This will affect your selection of tools in manufacturing. Now we have several methods to define tolerance. We have bilateral tolerance. In this case, you can allow for variation in both positive and negative direction from the nominal dimension. This means, for example, here, if you want to produce a shaft of diameter 2.5 centimeter, let's say, you say that I can have a tolerance of plus 0.005 or minus 0.005. So the final diameter can be or 2.495. Okay, so this will, sorry, 495. okay, or it can be 2.505. So here you have, this is why it's called bilateral tolerance, because you are able to have a smaller or higher diameter. And for this tolerance, it can be balanced, like this example, or also sometimes you can have a tolerance that is not balanced. So for example, you can say, I want maximum a diameter of 2.51, why I want minimum a diameter of 2.495. So in this case, the tolerance will be plus 0.01 and minus 0.005. So this is an unbalanced tolerance. In other cases, you might have tolerance just from one side. This is called unilateral tolerance. So you can have a dimension or higher than the specified dimension or lower than the specified dimension, but not in both directions. Okay. So the variation can be either positive or negative, but not both. Now, what is the meaning of limit dimensions? Limit dimensions constitute the minimum and maximum dimensions allowed. So, as the example we have taken together, the minimum dimension will be 2.495, and the maximum one will be 2.505. Now, what is measurement? Measurement is a procedure in which an unknown quantity is compared to a known standard one. This is why I told you when you specify a certain scale, okay, just it's a reference for you and you follow. This is why it's a subjective if you want a way to define. You can now you can define any new unit, okay, and it will be it can be used as a measurement tool. So measurement provides a numerical value of the quantity of interest with certain limits of accuracy and precision. Now, what is accuracy and precision? It's different. We should know the difference between them. Okay? Accuracy is the degree to which a measured value agrees with the true value of the quantity of interest. So if I have a certain quantity and I am doing measurement, accuracy is how much my measurement is close to the real value. Okay? So a measurement procedure is accurate when it avoids systematic errors between the true value and the measured one. On the other hand, precision is the degree of repeatability in the measurement process. So let's say if I measured several times and I got close results, this means that I have a good precision, but this does not mean I have a good accuracy. Because, for example, if you have sometimes, in experiments, you need to tune your experimental equipment. If it's not tuned well, let's say, it will give you the same repeated result, but it is far from the actual result. So in measurements, we try to have both accuracy and precision. Okay. So we will see here an example to understand more what is the difference between accuracy and precision. So here, for example, if you try to reach the goal, which is the center point, if you try to several times, if you try to reach it, the first figure represents high accuracy and high precision. Why high accuracy? Because all points are nearly close to the center. And why high precision? Because all your repeated shots are close to each other. Okay. However, in the second figure, you tried several times, but you weren't able to reach the center. So it's not an accurate case, but it's of high precision because all your trials were nearly at a very close point. Okay. On the other hand, in figure 3, you have several trials. These trials are close to the center, but they are not repeated in the same location. So you can say that here I have accuracy, but I have low precision. And in the final example, I have low accuracy and low precision because all my points are far from the center, and also they are not at locations close to each other. So I don't have accuracy and I don't have precision in this case. Okay. Now, what are the conventional measuring instruments and gauges? So we will see here several types of instruments, and in the YouTube links, I tried to search for videos for these different instruments to see how we use them in experiments. So you have the precision gauge blocks, you have the measuring instruments for linear dimensions, you have some comparative instruments. When we say comparative instruments, they are just used to compare lengths. and you will see how. You have fixed gauges and angular measurements. So let us go over them. So first, what is precision gauge blocks? Precision gauge blocks consist of, they are standards against which other dimensional measuring instruments and gauges are compared. They are usually square or rectangular blocks, and their surfaces are finished to be dimensionally accurate and parallel to plus or minus several millionths of an inch and are polished to a mirror finish. So gauge blocks are manufactured in a very accurate way. So the surfaces are nearly perfectly smooth, okay, and they are manufactured in a way to give you an error, a very small error. Okay, so the error is to the several millionths of an inch. The precision gauge blocks are available in certain standard sizes or in sets, the latter containing a variety of different sized blocks. So we will see here in a figure how you have precision gauge blocks. And the price of these blocks will increase a lot with the finishing. And higher is the surface finishing, higher will be the price of these blocks. Okay. So as you can see here, for example, on each block you will have written on it, it represents which dimension. So let's say, for example, let's say this is 5 inch. They put close to the block 5 inch. So if you need to measure very accurately a length, you can put these blocks, since they have very flat surfaces, when you put them near to each other, they will attract each other. So you can form any length you want from these blocks, and you can go to very high precision, because you have here, you have from, let's say, 5 inch maybe to 0.000 something of inch. So you can measure very accurate dimensions. Okay. And you have a video to show you how they attract each other and how you can select several ones to form a certain length you want. Now, how to measure linear dimensions? Measuring instruments are divided into two types. You have graduated measuring devices, which include a set of markings on a linear or angular scale to which the object feature or of interest can be compared for measurement. So you are familiar a lot with graduated measuring devices. You use them a lot. You have the rule, okay, and you have also a device for the angles like this, and these are graduated because you have graduation to tell you what is the length. Okay, so this is graduated measuring devices. On the other hand, you have non-graduate measuring devices that will not have scale, and they are just used to compare dimensions or to transfer a dimension for measurement by a graduated device. What do we mean by this? So, for example, let's say you have, we will see a lot of devices, okay, that are not graded, but what you have is the following. So let's say you have a tool like this. I will let us see the figure, it's better. You can see it down. For example, here, this is a non-graduated tool, okay? So you might put an object between the ends of this tool, and then you can, let's say it's a very, let's say this is, you put the object here, for example, okay? And you want to measure this length. So this is not graduated, but you can transfer the length. So once you determine that you want to find this length, you can transfer this length from the non-graduated tool to a graduated one. And you will tell me why I will not directly use a graduated one, because look, sometimes, for example, for a ball diameter, it will not be easy by the rule to find actually the diameter in a very accurate way. But when you put it in this tool, okay, you can trap it between the two ends, and you can then transfer the length to calculate the actual diameter in an accurate way. Okay, so this is non-graduated tools, and they are used a lot in experimentation. Now let us see some more advanced tools other than the rules for measurement of dimensions. So you have, for example, the external micrometer. Why we are saying it's external? Because it's able to measure uh, external sizes. So if you have, for example, we will see together that a micrometer that measure external sizes are different than a one measuring internal ones. Because look, let's say if you have a ball and you want to measure its diameter, this is a very good tool to use. You put the ball and you can find the actual measurement. However, if you have, let's say, a hole, okay, for a hole, this is not the accurate tool because you will not be able to enter it inside. So you have another tool that will allow you to measure internal dimensions. Okay, so this is a tool that can allow you to measure internal dimensions. It's the vernier caliper, okay? And we will learn next time together how to measure in a very accurate way. You have two scales here, okay? You have a larger scale and a smaller one. Uh, and this will allow you to measure very accurately a certain dimension. Now the vernier caliper can measure both internal and external sizes because, for example, if you have just an external a ball, you can put it in between and it's fine. And if you have a hole, you can just plug it inside, and then يعني, by moving this, you can measure the actual dimension. So for the vernier caliper, it can be used for internal and external measurements. Now, this is another type of calipers. These are two sizes of outside calipers. We say it's outside calipers because they are able to measure external lengths. Okay, you put the object in between and you can calculate the length. Now, what about mechanical gauges? Mechanical gauges are designed to mechanically magnify the deviation to permit observation. So you know that sometimes if I want to measure to a very accurate level, I need to have like a magnification scale to be able to see this. And this is the case in vernier caliper, and we will go with it in result next time. So here you can see here we magnify in this scale the measurement to measure very small lengths. Okay, we'll see it in detail because it needs time to explain it. And also you can find it in the YouTube links I posted for you. But we'll go in detail and we'll take examples next time. Now, most common instrument in this category is the dial indicator. So sometimes to magnify the reading, what we do is we convert and amplify the linear motion of a contact pointer into rotation of a dial. So by rotation into the dial, we can magnify the deviation to be able to measure the accurate length. The dial is graduated in small units such as 0.01 millimeter or 0.001 inch. The applications for these gauges are, of course, to measure very small lengths or to measure straightness, flatness, parallelism, squareness, roundness, and runout. What do we mean by this? So, for example, if you have, we'll give you here, so this is the figure of a dial indicator showing the dial and the graduated face. You can see how it is here. It's very clear, the graduation on it. We will see here an example to measure roundness. What do we mean by this? So if you want to make sure that your cylinder is perfectly manufactured, that you have a uniform diameter over your cross section, what you can do is you can put it in this setup. In this setup, what will happen is that the contact point will move over the cylinder, okay? And if you have any deviation from the required radius, it will cause a certain fluctuation in your dial, and it will give you what is the fluctuation from the desired radius, okay? So in this way, you can determine the tolerances of your manufactured process. Now, of course, with advancement in technology, electronic gauges are now the most one used, but still in our labs, because of the high cost of these gauges, we are still using mechanical gauges. Okay, so electronic gauges are family of measuring and gauging instruments based on transducers capable of converting a linear displacement into an electrical signal. Electrical signal is amplified and transformed into a suitable data format, such as a digital readout. Applications of electronic gauges have grown in recent years due to the technological advancement, okay? And this is due to microprocessor technology and computer technology that are replacing many of the conventional devices. So this is an example of electronic gauges. So it will directly give you the measurement. It will, instead of reading the measurement yourself, it will directly give it in a digital way in this case. So of course, this is more accurate. You don't have to do anything, just you should read the value. Now, other gauges, type of gauges used are go, no-go gauges. They are named like this because one gauge limit allows the part to be inserted, while the other will not. Okay. Now, the go limit is used to check the dimension at its maximum material condition. To understand this, let us see what is the go, no-go gauge here. Okay. So look, let's say you want to measure the diameter of this ball. Okay, in a go no go gauge, what will happen is that you have several set of gauges, and each one, let's say for example this one, let's say is, you say this is 5 centimeters, for example. Okay, now if you put your ball in order to trigger the actual measurement, it should be able to pass over the go button, but it will not be able to go over the no go gauge button. This means that the actual dimension of it is 5 centimeters. Okay, because here the difference between the go and no go gauges are very small. Okay, so it's order of 0.00 something. Okay, so whenever your ball can pass through this the go button and cannot pass through the no go one, this means that this is the actual size of it. Okay, and why we say that the go gauge will permit to measure the maximum condition of material, because what will happen here, imagine that this is the material you have. Okay, the material of your ball. Okay, once you trigger the ball between the two sides, okay, this will give you the maximum size of the ball your ball can have. Okay, it cannot have a lower size. This is why it's called the maximum material condition. While if you are measuring from an inner dimension, okay, it's called the minimum material condition. Okay, so we will see an example of this. So we say that the go limit is used to check the maximum material condition, okay? While the no-go limit is used to inspect the minimum material condition. And in this case, if you are measuring an internal feature, then the go limit will give you the minimum size for the internal feature, while it will give you the maximum size for the external feature. This is why we say that it's a measurement of the maximum material condition. Okay, because look, if you have, let's say, a hole, the go limit will give you the minimum size of the hole, and the minimum size of the hole corresponds to minimum material. Okay, and also if you are measuring an external dimension, the go limit will give you the maximum size of the external feature. Okay, and therefore it is a representation of the maximum material condition. On the other hand, the no-go limit is the opposite. Okay, because it is used to inspect the minimum material condition, since it will allow to find the maximum size of internal feature and minimum size of external feature. Okay. Now, this is the plug gauge. The plug gauge is a type of gauge and based on the same principle, but this one is mainly used for measurement of holes, okay, or of internal measurements. So you have the go no go plug. As usual, if you have a hole and you want to measure it, the plug will give you the minimum value of the hole diameter, okay, and in this case you can measure an internal length. Now, for angle measurement, you have also like vernier scale, but instead of having a linear measurement, you have it on an angular scale. Okay, and also we will learn how to read measurements from these devices next time. And you can find the way to read them using the YouTube links. So if you can go over the YouTube links this weekend, it will be good because it will help you to introduce you to the next session. Now, what about characteristic of surfaces? A nominal surface is the designer intended surface contour of part defined by lines in the engineering drawing. Now, nominal surfaces appear as absolutely straight lines, ideal circles, round holes, and other edged and surfaces that are geometrically perfect. But in real case, actual surfaces of a part are determined by the manufacturing processes used to make them. And more accurate the manufacturing process is used, more the final surfaces will be close to the ideal ones. So we have a variety of processes that will result in wide variation in surface characteristics. Now here, for example, you can see surfaces obtained by different manufacturing processes as horizontal milling, vertical milling, and turning. All these processes will be studied in detail in this course, okay, in future chapters. But you can see, for example, that the finish of the surface will vary depending on the manufacturing process that we use. Now, the characteristics of surfaces are very important for variable reasons. First, for aesthetic reasons, for the safety, and sometimes, let's say, if you have an internal combustion engines, you should have perfectly smooth surfaces between the piston and the cylinder to ensure smooth motion of the piston. Okay, if not, you will have with time you will have corrosion, okay, and wear of your different parts of your engine. Okay, so the properties of surfaces are sometimes will affect a lot the safety of the equipment. Now, friction and wear depend on surface characteristics. Okay, and in general, we try to reduce friction and wear in manufacturing, especially for the tools used uh, to, to perform the manufacturing process. Now, the surfaces will affect the mechanical and physical properties also. And the assembly of parts is affected by their surfaces, of course. So when you want to assemble two surfaces together, they should have appropriate characteristics of surface to be able to join them. And finally, smooth surfaces make better electrical contact. So in the electronic field, it's very important to deal with smooth surfaces. Now, what is surface roughness and surface finish? Surface roughness is a measurable characteristic based on roughness deviations. The surface finish is a subjective term denoting the smoothness and general quality of a surface. In general, in popular use, we say that surface finish is often used also as a synonym for surface roughness, and both of them are within the scope of surface texture. Okay. Now we will define together what is surface roughness. Surface roughness is the average of vertical deviations from nominal surface over a specified surface length. So as you can see here, I have, in general, if I have a perfectly smooth surface, it will be like this. But in real cases, I might have certain roughness of my surface. So I will have deviation in both directions, in positive and negative one. Okay. And in order to measure the roughness, I can use the following formula. I can say that the roughness can be calculated as the arithmetic average based on the absolute values of deviations and is referred to as average roughness. So over a certain length of my specimen, I can define roughness as integral of the absolute value of the deviation. Why I take the absolute value? Because I can have positive or negative deviation. Okay, so it's integral from 0 to the final length of the deviation over Lm dx. And higher is the roughness, higher will be the deviation, and the farthest I will be from the smooth surface. Okay, where Ra represents the average roughness, Y is the vertical deviation from nominal surface, and Lm is the specified distance over which the surface deviations are measured. Now, another possibility to measure roughness, instead of doing integration, I can choose a high number of points. So if I choose a high number of points on the surface, okay, I can say that in approximation, instead of doing integration over the whole length, if I take a high number of points, it can be the roughness can be approximated as the summation from I to n of the absolute value of deviation over the number of elements I am considering. Okay, so this is an easier way to define roughness, because if you want to do integration, you want to have infinity of measurements to be able to draw y function of x and then to do the integration procedure. So to facilitate this measurement, what we can do is we can take several points on the surface like this. Okay, and for each point we measure the corresponding deviation, and then the value of roughness can be calculated. Okay, so any question until here? So we continue next time. Okay, so next time, please, during this weekend, try to go over the YouTube links I posted for you on Blackboard. Okay, for this chapter, and I think it's called chapter 3 links. It's called chapter 3 because if you want, it's the third chapter. If we consider, yeah, the first one is just an introduction. But I will fix this for you to not confuse you. I will put chapter 6 links. Okay, so you can all go over these YouTube links to see in live how we do measurements and what are the different types of measuring force. And we continue this chapter next time. Okay, thank you.